Morning students, how are you all? Hope you all are safe and fine at your home. So welcome back students in your mathematics class. This is class 9th, chapter 13, surface areas and volumes. This is our lecture 2. In first lecture we discussed about cuboid and cube. In the second lecture we will discuss introduction of right circular cylinder. We will learn all things about a right circular cylinder and the formula derivation of cylinder. Formula derivation for cylinder. So students, first question is this: what is cylinder and what is right circular cylinder? So students, when we have a number of circular sheets, of paper or something other and when with some thickness, and when we put these sheets on each other like a stake, then if the stake is keep vertically up, we get what we called it as right circular cylinder. Why right circular cylinder? Because we called it as axis. The line segment joining the two centers of the two bases is called the axis of the right circular cylinder. When we have some number of circular sheets and we will put on each other and make a strike like that, and then we called it as right circular sheet. And when we will put these sheets, when they are not correctly present on each other and when they are looking like that, then we called it as simple cylinder. So students, if we will take a proper cylinder, then it is a right circular cylinder and it is axis which join the two centers of the bases. This is the upper part, this is because it is circular, this is the center, and this is also circular, this is the center. We called it as axis. The line segment joining the centers of two bases called the axis of the cylinder. So a solid, what is the definition of the cylinder? A solid generated, a solid figure or solid thing generated by the revolution of the rectangular about its sides is called a right circular cylinder. Now I know you are thinking, what ma'am said, where is it rectangle, where is revolution, and what about the revolution of rectangle? So I will explain, wait. So this this is our base and we have two circular faces, and this one we have as a round face, and this is our axis, this is our radius in cylinder, this is also a radius, and this is our height, of the cylinder. So the length of the axis is called the height of the cylinder. Now the question is, what are the total in this we have total 3 faces, and what about the lateral face? Which one is lateral face? The curved face, this curved face joining the two base is called the lateral surface or lateral face of the right circular cylinder. Now I will show you how we will make a cylinder and what is a rectangular revolution about the cylinder. Student, this is a rectangular sheet. And in this rectangular sheet we have length and we have breadth. When we will fold this circular sheet like this, then now this is a cylinder. We called it as cylinder. So this is a first circular base, this is our second circular base, and this part is the curved surface which is present, which is the third face of the cylinder. This is the curved part of the cylinder. So we have total 3 face, first, second and third, this one curved face. So student, you remember in the first lecture I explained the difference between lateral surface area and the curved surface area. When the lateral faces, this is the lateral surface of the cylinder, because when we will put it here, then I already explained to you what is the lateral face. Those faces touch the base of the given figure is called the lateral faces. So this circular face touch the base, so we called it as lateral face. But we use words lateral for those when we have the straight surfaces with the straight line, but now we have a curved surface, so we will call it as curved face. Okay, remember? So now we have this type of cylinder. Now the question is what is the use of this rectangular sheet? Now the student, it will help you to find the area of the curved surface area of this curved face. So student, this is length and breadth of this rectangular sheet, and you know it very well that area of this rectangular sheet is length into breadth, length into breadth. When we will fold this circular sheet, taking breadth as length, so B is equal to H, because B is now the height of the cylinder, and now L is, which is the length of the circular sheet, is the circumference of the circle, and it is not compulsory that we will take breadth as a height always. It is also possible when we will take this length as a height. Now it is also a cylinder. Here we are taking length as a height, and now breadth is the circumference of the circle. Now students, I will show you how we will find the curved surface area of cylinder. So curved surface area of cylinder, which is the area of curved face, or we can say as surface. Okay, so area of the curved face or the area of curved surface, which is length into breadth always. If we will take length as circumference of the cylinder and breadth as the height, so we will put that circumference of the cylinder is 2 pi r and breadth is as h. If we will take length as h, then we will put breadth as circumference of the circle 2 pi r. So it's our choice, but the answer will be same. So the curved surface area of the cylinder is 2 pi r h. Now total surface area of cylinder, which is area of first face plus second face plus third face, correct? So area first face is circular face, so the area of the circular face is pi r square. When we will see this diagram again, then this is a shape of circle, so the area of the circle is pi r square. First area face, second face, and this one is third face. So again the area of the second face is pi r square, and the area of third face, which is the curved face of the cylinder, which is area of the curved face, is 2 pi r h. Now we have 2 pi r square plus 2 pi r h. We will take 2 pi r as common, then r plus h. This is the total surface area of curved cylinder. We will take this also, and this also. Choice is completely yours. Now students, we will do some questions of exercise. So the first question of exercise 13.2 from NCERT. which is the curved surface area of a right circular cylinder of the height 14 centimeter is 88 centimeter square. So if you are not able to understand the meaning of the line, so you have to read it again. The curved surface area of a right circular cylinder height is 14 centimeter and the curved surface area of the cylinder is 88 centimeter square. So what we have? Curved surface area of cylinder is 88 centimeter square and height is 14 centimeter. Find the diameter of the base of the cylinder. It means first of all we have to find the radius, then we will find the diameter. So we know it very well that curved surface area of the cylinder is 2 pi rh. Here r is the radius, h is the height of the cylinder, which is 88 centimeter square. Unit, don't forget. Now we will put the values. So pi is 22 upon 7, r we don't know, h is 14 centimeter, which is equal to 88 centimeter square. Now we will solve. 7 1 is 7, 7 2 is 14. Now we have 88 centimeter into r. So now we will write like this. Shift to the other side because we have to find the value of r, which is 88 centimeter square divided by 88 centimeter. 1 centimeter cancel with the 1 centimeter and 88 ones are 88. Then r is equal to 1 centimeter. And we know it very well that diameter is equal to 2r, which is equal to 2 centimeter. This is your first question. Now second question. Second question of exercise 13.2 from your NCERT based on cylinder. It is required to make a closed cylindrical tank of, okay, we will take question number 3 because 2 is very easy and it is like the first question. 3. A metallic pipe is 77 centimeter long. A metallic pipe. He is talking about a metallic pipe. And the inner diameter of the cross section is 4 centimeter and the outer diameter is 4.4 centimeter. Now the student, I choose this question because I know that you will confuse between what is the inner diameter and what is the outer diameter. That's why I leave this question number 2nd and choose third one. So we have a pipe like this because in pipe we have some thickness. So it means we have a small triangle inside a bigger triangle. If students, if we will take this cap of the pen, forget about this part. This is a proper example of the cylinder. This is a proper example of the cylinder. This pen has some thickness. This cap has some thickness. This internal part is called the inner cylinder and this is called the outer cylinder. So the radius diameter which is present the inside of this is called the inner diameter, and when we will take a diameter from this edge to this edge, then this is the outer diameter. So it means inner and outer means we have some thickness. It means the pipe, when you will see some pipes in your home, then you will see that it has some thickness. So the inner diameter is this part. Inner diameter is 4 centimeter and the outer complete diameter is 4.4 centimeter. It means thickness of this thickness. How we will find the thickness? For finding the thickness, first of all we have to find the radius. Inner diameter of the cross section is 4 centimeter. It means small r is 2 centimeter. And the outer, it means capital D is 4.4 centimeter. It means capital R is 2.2 centimeter. So if we are going to find the thickness, then it is capital R minus small r. Remember one thing, I am again explaining this question, that when we are going to find the thickness, we are not using diameter, we are using radius, because when we are talking about the radius of this small and then radius of this bigger. So this is 2.2 minus 2 centimeter, then 0.2 centimeter is the thickness of the pipe here. And what is the given other thing? Height is 77 centimeter. So we are going to find three things. First, we have to find the inner curved surface area. What? Inner curved surface area of cylinder. We know it very well that the formula for finding the curved surface area is 2 pi RH. But when we are talking about inner, so we will use small r. 2 pi small r h. This is 2 into 22 upon 7 into small r is 2 centimeter, and then h is 77 centimeter. This is centimeter square. Then we will cancel. Then it is 2 2s are 4. Then 88 multiplied by 11 centimeter square. Then it is 968 centimeter square. Now the second part of the question, when we are talking about outer curved surface area of cylinder, which is 2 pi r h, and when we will put the values, radius is 2.2 and centimeter, height is 77 centimeter. Now it is centimeter square. When we will solve, it is 1064.8 centimeter square. So now the third part of the question, sorry, this is second part. Third part is total surface area of cylinder. Now the question is, always student confused. Now they will take small r or the capital R. Now he is asking about total surface area of the cylinder. Total surface area of the cylinder. So the total surface area of the cylinder is inner curved surface area plus outer curved surface area, and the area of the two bases also. Area of the two bases also. So it means area of, when we are talking about this with the thickness, area of outer surface area, inner surface area, because we have some whole part here also, and the area of this circular part and area of this circular part. If we will take this as S1 and then S2, so the total surface area is S1 plus S2 plus two circular parts which is present upward and the downward which is as double of pi r thickness, pi r square minus pi r square, because we are taking about thickness, because it is a pipe and it is not completely solid. We have to take the area of this thin line only. So how we will find the area of this thin line? This is the upper part of this figure. This is the upper part of this figure like this. So we have to find the area of this part only as a upper and the base of the. So this is bigger circle. If we will take area of this bigger circle and then subtract area of this small circle, then the area of this thickness will be appear. And we have upper as well as down part, so we will multiply it with the 2. When we will put all the values and solve it, then you will get the solution. You will get the solution of the total area of the metallic pipe, which is as 2038.08 centimeter square. Try to solve and do the calculations very carefully. Now students, homework, solutions of lecture 1. In this lecture 1, I will take 5th question of exercise 13.1. Sorry, question number 7. So student, question number 7 from your NCERT of exercise 13.1 is Shanti sweet stall was placing an order of making a cardboard box for packing of their sweets. The two sides of box were required. The bigger of the dimension is 25. So we have to write for the bigger box, dimensions are 25 centimeter multiply 20 centimeter and 5 centimeter. For the smaller box, Dimensions are 15 centimeter multiply 12 centimeter multiply 5 centimeter. For all the overlaps of 5% of the total surface area is required extra if the cost of cardboard is 4 rupees per 1000 centimeter square. Remember student, per 1000 centimeter square need 4 rupees. Most of the time student take it as 1 centimeter square and do the question, and then answer will be wrong. So student, remember one thing, it is given that 1000 centimeter square. Find the cost of cardboard required for supplying the 250 box of each kind. It means we want 250 bigger boxes, 250 smaller boxes. So the question is, someone want to sweet boxes and he or she wants a 250 smaller box and 250 bigger box, and measurements are already given, and he said one thing that he needs she needs 5% for the overlapping. What it means, students, see, when we will cover our book, then we will fold some part inside, like our sweet box also. If you saw sometime clearly that some part is also folded inside the boxes also, which paper is pasted on a sweet boxes, which is also present inside part, because it is necessary for pasting the paper. So we will need 5% for that also. So now total surface area of, we will take bigger boxes as S1 and smaller boxes as S2. Total surface area of S1 means bigger boxes. We know that it is 2 into LB plus BH plus HL, because it is an example of cuboid. So we will put the values. Then it is 2 into 25 into 20 plus 20 into 5 plus 25 into 5 centimeter square. So it is 1450 centimeter square. Now the total surface area of small box, which is, again we will put the same formula, 2 into 15 into 12 plus 12 into 5 plus 15 into 5 centimeter square. Now it is 630 centimeter square. So we will add the areas of both boxes, because we need 250 each, which is S1 plus S2 is 2080 centimeter square. Now the area of overlaps, because we have to take this also, which is the 5% of the total. So we will take 5% of the total, which is 104 centimeter square. Now the total surface area of two boxes, which is 2080, plus we will add that overlapping part also, which is equal to 2184 centimeter square. Now we will need 250 boxes for the each kind, and the both sum of the both the areas are this. So total surface area of 250 boxes, 250 multiplied by 2184 centimeter square, which is 54600 centimeter square. Correct? So students, now cost of cardboard for 1 centimeter square is 4 upon 1000 rupees, and then cost of cardboard for 250 each kind is 4 upon 1000 rupees multiplied by 54600, which is rupees 2184. This is the complete answer of your question number 7. Question number 7. So student, I also want to discuss one thing with you, that in question number 6 we have to find the area of 12 edges, and it is completely, the meaning of this line is the perimeter of the cuboid. In cuboid we have 4 length, 4 breadth and 4 height. So definitely I am giving the hint of question number 6, second part, that perimeter of the cuboid. It means if we are going to find the total tape which we are pasting on the 12 edges is 4 length plus 4 breadth and 4 height. We will take 4 as common, then this is the formula for that part. So now the students, your lecture is just over and now your homework. So today's maths homework is, you have to do all remaining questions of exercise 13.1 and exercise 13.2 and learn and write derivation of cylinder formula. So you have to learn the derivation and you have to understand also, and you have to do the question of exercise 13.2. At least try all the questions. Thank you. Have a nice day.